Hi, let's take a look at solving this problem. We want to solve this by factoring. And what we're going to do is first we're going to get a 0 on one side of the equals by subtracting 1080x from both sides. That leaves us 0 on the right, 5 times x to the fourth minus 1080x on the left. So the greatest common factor of these two terms is 5x. And I need to multiply 5x by x cubed to get 5x to the fourth. And I need to multiply 5x by 216 to get the second term on the left side of the equals, negative 1080 times x. Now, one of the things that's needed here is a piece of information that we study in intermediate algebra. So the class before this one, we studied this idea of a difference of cubes, sometimes called a difference of two cubes. But I'm going to just write it as a difference of cubes. And that's a factoring formula that says a cubed minus b cubed is equal to a minus b times a squared plus ab plus b squared. Now, this is a formula that it's assumed you know. So if you don't know it, that could be problematic because you'll be wondering where things are coming from. And we need that here because x cubed minus 16 is x cubed minus 6 cubed. So in a problem like this, we're using this difference of cubes formula. Instead of a, we have x. Instead of b, we have 6. So our a minus b is x minus 6. Our a squared is x squared. Our ab is x times 6, which we can write as 6x. And our plus b squared is plus 6 squared. And so we now have this factored. And as long as our factor, so here we have 5x is really 5 and x are a factor. X minus 6 is a factor. And x squared plus 6x plus 36 is a factor. And this happens to be prime. You can't factor this quadratic polynomial or second degree polynomial over the integers. So we can set 5x equal to 0. So we take each factor that has the variable in it and set it equal to 0. So we take x minus 6, we set that equal to 0. And then we take x squared plus 6x plus 36, and we set that equal to 0. And so we're going to find the solutions to this equation by solving these three equations. So the first equation, 5x equals 0, I divide both sides by 5, and I find out that x is 0. Okay, so that's one of my solutions. X equals 0. Then I add 6 to both sides of this second equation, x minus 6 equal to 0. And that allows me to find out that x is equal to 6. So that's another solution to my equation. And now to solve x squared plus 6x plus 36 equals 0, I'm going to use the quadratic formula where a is 1, b is 6, and C is 36. So my x is going to be negative b, which for this case would be negative 6, plus or minus the square root of 6 squared minus 4 times 1 times 36. 4 times a times c. All over 2 times a, which is 2 times 1. And I'm going to do something a little interesting here. I'm going to, I'll talk about this in the next step. All right, so for the moment, I'm going to leave this as the radicand as 36 minus 4 times 36. And here's why I'm going to do that. In order for me to simplify that radical, it's easier for me to leave this like this. And I'm going to think of this as 1 times 36 minus 4 times 36. So that's the same as having something of the form 1x minus 4x, which would be a negative 3x. But instead of x, we've got 36. So 136 minus 4 36s is negative 3 36s, or negative 3 times 36. So the reason I do that is because it saves me a little bit of time. I need to take this radical and I'm going to write it as the product of 3 radicals. My first radical, I'm going to have the perfect square, square root of 36. My middle radical, I'm going to have the square root of negative 1. And then my last radical, I'm going to have the square root of 3. And I see that these radicands multiply to give negative 3 times 36. And so leaving it in that form just saved me a little bit of time. So this result is that x is negative 6 over 2 plus or minus 6i times the square root of 3 over 2, which is negative 3 plus or minus 3i, 6 divided by 2 is 3, 3i times the square root of 3. So my solution set to this problem is the set containing 0, 6, negative 3 minus 3i square root 3, and negative 3 plus 3i times the square root of 3. Now, you asked about taking the square root of a square. I don't know if you really meant that or if you were just talking about this problem. But if I take the square root of something squared, and I don't know this, so if I take the square root of x squared and I don't know whether x is positive or negative, that's the absolute value of x. So, for example, the square root of the square of negative 5 is the absolute value of negative 5, which is 5. So I only have this issue if what I'm squaring was negative. So if I have the square root of 5 squared, that's simply 5. So the square root and the square are opposite operations. One cancels out the effect of the other. So I don't know if you really needed this or if your problem was really just about this question. So this is the result. Hope this helps.